Hello friends, so in today's question, a block of mass small m is placed on an inclined surface of a wedge as in the figure. Calculate the acceleration of the wedge and the block when the block is released. Okay, so this is the wedge which is having a mass of capital M, and this is a small block of mass m which is placed on the inclined plane, and it is said that all the surfaces are frictionless. So this we can say that mass of the block is equal to small m, and mass of the wedge is given as capital M. Okay, so in this case we draw the free body diagram of capital M as well as small m. Okay. So in this case, let us draw first of all the free body diagram for the this is the wedge which is having the mass of capital M, angle is given as theta, and somewhere here we draw block mass small m, and this is small m. Now there will be a normal interaction between capital M and small m. Okay, we can draw it like this. So it will be acting in upward direction here, and here it will be acting in downward direction, and this normal is going to have two components, can be divided rather into two components. So we are going to have this angle will be theta, so obviously this will be n cos of theta, and this will be n sine of theta, and normal here can also be divided similarly. This will be angle theta, we are having this will be n sine of theta, and this will be n cos of theta. There will be mg which will be acting in the downward direction, and the coordinate we can say that we are going to take x and y in this direction. Another thing, we assume that the wedge is moving with the acceleration of capital A towards left, and we have mass small m which will be moving in the downward direction, let us suppose with the acceleration of small a. So this acceleration can be divided into two components. So this will be angle theta, so we have a cos of theta, and this will be a sine of theta. So these will be the various components. Normal, we have mg and other things. Okay, now we already said that acceleration of the wedge is taken as capital A, and acceleration of block is taken as small a, and acceleration A is towards left, and this A is along the inclined plane, along the inclined plane. So as per the free body diagram, you can say as per free body diagram, we get, okay, we are going to get various equations that will be associated with free body diagram. So we can say that for mass capital M, for mass capital M, we can say that we are going to have acceleration is towards left, and there is the only component n sine theta which is of the normal, which is towards the left. Okay. So we can say that n sine of theta will be equal to mass into acceleration. Let this be equation number 1. Now we find out for mass small m, we can say that the acceleration is in the downward direction and it has a component of a cos theta towards the right. Okay, so we can say that n sine theta is the first component plus, okay, another thing, there will be a pseudo force which will be acting in this direction and whose magnitude will be equal to small m capital acceleration. Okay, this will be our pseudo force. So we have n sine theta plus ma is equal to, we have ma cos of theta. Ma cos of theta, this is equation number 2. And in the vertical direction, we have mg in the downward direction, so we can see mg, and there will be a normal which is acting in upward direction, that is n cos of theta, and the acceleration is given as ma sine of theta, and this is equation number 3. Okay. So we are going to use these 3 equations and subsequently find out the value of acceleration of the wedge and acceleration of the mass. Okay, so first is from equation 1, using, or rather we can say using equation 1 in equation 2. So we are going to simply substitute n sine theta is equal to ma in equation 2. So we get this as capital Ma plus small ma is equal to ma cos of theta. From here we can find out what will be our ma. Ma will be equal to capital M multiplied by a plus ma divided by cos of theta. Let this be equation number 4. So we use the equation number 1 in equation number 2. We substituted n sine theta as ma. So we get ma plus small m into a is equal to ma cos theta. From here we found out ma is equal to this value, simply cross multiplying it. And similarly, we are going to use again equation number 1 and find out what will be the value of the normal. Okay, so we can say that from equation 1, n is equal to ma divided by sine of theta. Let this be equation number 5. So now we are going to use using equation 5 in equation 3. So we are left with mg minus substituting value of n, that is ma divided by sine of theta multiplied by cos of theta is equal to ma sine of theta. And let us call this as equation number 6. Now we are going to use the value of ma from equation 4. Using equation 4 in equation 6, we get this will be equal to mg minus ma sine of theta into cos of theta, and our ma, it is given as capital plus small divided by cos of theta into sine of theta. Now we are going to move this a to one side, so we are left with capital M plus small m divided by cos of theta. We have a as common, and this is sine of theta plus ma divided by sine of theta into cos of theta is equal to mg. Now taking a common from the entire, we are left with m plus m sine of theta divided by cos of theta plus capital M cos of theta divided by sine of theta is equal to mg. Now taking the LCM, so a cos theta and sine theta product will be LCM, so we can say that this will be equal to m plus small m. Here will we get this sine square theta plus capital M cos square theta, and cross multiplying here, this will mg cos theta to sine theta. We open the bracket, we get a, this will be m sine square theta plus capital M cos square theta plus m sine square theta is equal to mg cos theta into sine theta. Now this term, we're taking m as common, this will be sine square plus cos square, which is 1. We can say that a, we get m plus small m sine square theta is equal to mg cos theta sine theta. And finally we get value of capital A is equal to mg cos theta into sin theta divided by m plus small m sin square theta. So this is the acceleration of the wedge. Okay, nothing but acceleration of the wedge. Now we are going to find out the acceleration of the block having mass A. So we are going to use equation number 4. So we can say from equation 4 we get A is equal to m plus m into A divided by m cos of theta, putting value of A. Okay, let us call this as equation number 7 and this as equation number 8. So using equation 7 in equation 8 we get A is equal to m plus small m divided by m cos of theta, and putting value of capital A we get mg cos of theta sin of theta divided by capital M m sin square theta. Now m and cos theta cancels out, so we get A is equal to m plus m g sin of theta divided by m plus m sin square theta. So this is our equation for acceleration of the block mass m. Okay, so this is acceleration of block mass small m. This completes the question. Thank you.